Did you know that most of the universe is hidden from our eyes? We only see a tiny fraction of what's really out there? That there are mysterious forces at work that shape the destiny of the cosmos? And that we have no clue what they are or how they operate? For decades, scientists have been puzzled by one of the greatest mysteries of the universe: dark matter. It is a mysterious substance that we can't see, touch, or detect directly. But we know it exists because of its gravitational effects on normal matter and light. It makes up 85% of all the matter in the universe. It holds galaxies and clusters together, and it shapes the large-scale structure and evolution of the cosmos. But what is it made of? Where did it come from? And how does it interact with normal matter and light? In this video, we will reveal to you an amazing scientific breakthrough: the Nancy Grace Roman Space Telescope, and why it's likely to finally solve the puzzle of dark matter and dark energy. But before we dive into this cosmic mystery, make sure you subscribe to our channel, hit the like button, and turn on the notification bell so you don't miss any of our amazing videos. Who is Nancy Grace Roman? She was a pioneering astronomer who worked at NASA for 21 years and became known as the Mother of Hubble for her role in planning and developing the Hubble Space Telescope. She was also a champion for women in science and a visionary leader who inspired generations of astronomers. In 2020, NASA named its next flagship space telescope after her, in honor of her legacy and contributions to astronomy. What is the Roman Space Telescope? It is a Hubble-sized telescope that will revolutionize astronomy by building on the science discoveries and technological leaps of the Hubble and James Webb Space Telescopes. The Roman Space Telescope will have a 2.4-meter primary mirror, the same size as Hubble's, but with a view 100 times greater than Hubble's. That means it can capture more of the sky in less time and with more detail than ever before. The telescope will carry two scientific instruments: the Wide Field Instrument, also called as WFI, and the Coronagraphic Instrument, CGI. The WFI is a 300.8 megapixel multiband visible and near-infrared camera that will provide images with a sharpness comparable to that achieved by Hubble, but over a much larger area. The WFI will also have a spectroscopic mode that will allow it to measure the distances and properties of millions of galaxies and stars. The CGI is a high-contrast, small field-of-view camera and spectrometer that will use novel starlight suppression technology to directly image and characterize planets around other stars. The CGI will also be able to study the disks of dust and debris that surround many stars, which are thought to be the birthplaces of planets. What are some of the scientific goals of the Roman Space Telescope? One of the main goals is to unravel the secrets of dark energy and dark matter, which together make up 95% of the universe. Dark energy is a mysterious force that causes the expansion of the universe to accelerate over time, while dark matter is an invisible substance that holds galaxies and clusters together with its gravity. Scientists don't know what dark energy and dark matter are made of, or how they interact with normal matter and light. One way that the Roman Space Telescope will probe these cosmic mysteries is by using a technique called gravitational lensing. This is when light from distant objects is bent by the gravity of massive objects in front of them, creating distorted or magnified images. By measuring these distortions, scientists can map out how much dark matter there is in different regions of space and how it affects the expansion rate of the universe. Another way that the Roman Space Telescope will study dark energy is by observing supernovae, which are exploding stars that can be used as cosmic distance markers. By measuring how bright and how far away these supernovae are, scientists can determine how fast the universe was expanding at different times in its history. This can help them test different theories about what dark energy is and how it changes over time. Besides exploring dark energy and dark matter, The Roman Space Telescope will also search for and image exoplanets, which are planets outside our solar system. The telescope will use two methods to detect exoplanets: gravitational microlensing and direct imaging. Gravitational microlensing is when light from a distant star is magnified by another star that passes in front of it, revealing any planets that orbit around it. Direct imaging is when light from a planet is separated from its host star using a coronagraph, which blocks out most of the starlight. The Roman Space Telescope will also complement other observatories that study gravitational waves, which are ripples in space-time caused by violent events like merging black holes or neutron stars. The telescope will help identify and locate the sources of these gravitational waves and provide additional information about their properties and environments. This space telescope is scheduled to launch in next 3 years and will operate for at least 5 years. It will orbit around the Lagrange point 2, which is a stable point in space about 1.5 million kilometers from Earth, where the gravitational pull of the Sun and Earth balance each other. From this vantage point, the Roman Space Telescope will have a clear view of the sky and minimal interference from Earth's shadow or heat. The Roman Space Telescope will open a new window to the universe, revealing its mysteries and wonders in unprecedented detail and scope. It will answer some of the most fundamental questions about our existence and our place in the cosmos. It will also inspire new questions and discoveries that we can't even imagine today. We hope you enjoyed this video and learned something new. If you did, please give it a thumbs up and share it with your friends. And don't forget to subscribe to our channel for more amazing videos about the universe and beyond. Thank you for watching and see you next time.